with that, I would like to introduce Mahr and the gentleman from Mahr who is going to be presenting here today. So that is going to be George Schutz. He's the Director of Precision Gauges with Mahr. He's absolutely one of the highest level of experts within the industry. Having him present this is truly going to be a great treat for us here today. So with that, I'm going to kick it over to George, and he's going to take it away.
Okay, well, thanks, Steve, and thanks to all of you out there joining this webinar. Hopefully you find it valuable and learn some good things about air gauging. As Steve mentioned, if you have some questions, feel free to enter them in through your chat box, and we can address them during the webinar, or we can also take those offline later and get you some other more detailed information. So with that, let's start learning about air gauging. So we got some, it's always good to set objectives. So today's objectives are to understand why air gauging is a valuable dimensional measurement solution. And I think with today's tolerances, air is even more valuable than when it was first introduced. We're going to look at some air gauge theory. We're going to take a look at some of the applications for air gauging. And then we'll look at the information of what is needed for a customer to put air gauging to use and provide the right solution. So let's start diving into a little bit about air gauging. It's always good to talk about it in history because air gauging has been around, and I've been around with Mahr, but I haven't been around that long that I remember when air was first introduced, but pretty close. But air gauging was really introduced in the 40s. A company called Mahr Products, rather, that first introduced it. Sheffield Corporation was part of that theme at the time. And in 1945, Federal Products, which is the original company here for Mahr, introduced the Metricator. But this was really the first truly high performance tool for making precision measurements on the shop floor. It brought 50 microinches or 1 micron or better measurements to the point of manufacture. So as you can imagine, just after wartime, we're starting to get into aviation and aerospace. Tolerances really started to get tight, and this was a way to bring air gauging to the point of manufacture. It's always good to look at the first technical data that came out with the federal metricator in December of 1945, and I highlighted some of the just a couple of important sentences, and you can see that they're still relative today. So this marketing or training material talked about where does air gauging fit into the scheme of things. It's important because it had magnification higher than that was and still is available with dial indicators. Air gauging uses basically a non-contact method, so you don't have to worry about contact points dragging on sensitive parts, which is a good feature of air gauging. And because air gauging is made to the dimension that you want to manufacture, there's really no operator involvement involved in using air gauging. So virtually unskilled help can make very high quality measurements with air gauging. And all those things are same today. They're all true. Air gauging is a measurement system that allows for fast measurement. That's because it's made to the specific size. It's self-aligning. There's no rocking or searching for the high points. You put the plug into the hole, you get a great measurement. You get performance better to 5 microinches or 0.1 micrometer. Like I say, it's easy to use. There's little operator skills involved or influence available with air gauging. It's non-contact. There is no sensitive contact touching the part. Air pressure does that. Of course, the body of the plug is going to touch the part, but in terms of bringing or dragging a contact point across a part, air gauging will not mar the part. And because air is being forced out through the air plug or air ring, it's always cleaning itself. It gets rid of water-based contamination, and it's great for being used right at the point of manufacture. So those are all great features. And when do we use air gauging? Well, we use it for tight tolerance conditions, when part dimensions are greater than 3 millimeters. Because it is a variable measurement system, it gives us the information we need to make decisions about how good and how bad the part is, or start collecting data for process control. It's really good for high volume parts because we can make that measurement very quickly without operator influence. Great for fast production type environments. But it's also good for geometric measurements when you're doing tapers or straightness. Because of the small jet size, we can do some of those checks again right at the point of manufacture. And because the point of manufacture is dirty, that's a great environment for air gauging because it can blow away some surface contamination. Is air gauging difficult to apply? Well, not really. Air gauging is really no different than any other type of gauging solution, whether it be a snap gauge, an adjustable bore gauge, or even a caliper. What do you need to know? You need to know the size, you need to know what the tolerance is, you need to know where the measurement is being made. And as we see later on, surface finish can be important with air gauging. So we will ask, what is the surface finish of the part to be manufactured when we apply air gauging for that solution? But it's kind of important to know that if you make a mistake in specifying the size or the tolerance, you may have because it's made to the size and tolerance that you want to manufacture to, it may be an unusual measuring system. So we don't want to add any air plugs to that scrap pile that's out there. Let's get the information right, and air gauging is going to give you a great and dependable solution for your measurement. Now, how does air gauging work? Well, it's kind of along the same principle as a garden hose. You know, as you hold that hose against a wall, the distance there, it's going to build up pressure, and as you get closer and closer, eventually it shuts off. And what's happening? You're really restricting the water coming out of the hose. Well, the same thing can be happening with air gauging. You know, as you close off the water line, that pressure in the hose builds up. If you use air, the same thing happens. As you close off the air line, the pressure in the supply line builds up. And that's what's happening with air gauging. So you could think about the distance and the pressure change. And really, you can really start graphing out those things that are happening, whether it be flow, the water or the air coming out of the hose, or the back pressure that's building up in the hose. They're very similar curves, they're opposite, but if we look at the pressure, when the hose is completely restricted, we're going to have the highest pressure, and when it's wide open, we're going to have the lowest pressure, and that becomes our pressure distance curve. And as you notice here, there's a nice straight area of that curve. So if you can control the pressure, the nozzle size, the distance between the nozzle and the surface being measured, you can create a very linear, reproducible curve. Basically, build the accuracy into the air gauging system. And that's what we do at Mahr here. We build the accuracy into the system to create a very linear curve, which is used for making a distance or a portion of our measurement, and we can make very accurate, like I said, down to 5 microinches type of measurements with this linear curve. And it all really comes down to that jet. So if we can, the pressure distance curve is dependent on that jet as you can see in the air plug here, which the air flows through. And all air tooling, whether it be rings or plugs, have these jets. So as the air jet is restricted, we are measuring what's happening to the air, the back pressure that's happening in the system. So with a typical air tool, the air comes in, it's split between two jets. It's a differential measuring system. You restrict the jets, you get a dimensional measurement. So when we can control the air pressure, the manufacture and position of the air jet, the manufacture of the air plug, and calibrate and control the zero location of a pneumatic zero, we can produce a very repeatable and very accurate measuring system. And this is what Mahr does. We build the accuracy into our air gauge systems. And we also take the air tooling, we build the accuracy into that, but we also build the accuracy into our air display systems, as all our air displays are wrapped around a single master um, balanced air gauge system, so that this kind of represents the system we're using where the air comes in, but it's split between two channels, a measuring channel and a reference channel. So in case there, and we compare the difference between those two to get our reading. The benefits of this is that if there's any slight pressure, atmospheric pressure, pressure on the supply line that the regulator can't take care of, both channels are affected dimensionally, but will still get the same great results. So accuracy in the tooling and accuracy in the display system. So an air gauge system consists of that readout that we talked about with the balanced system for air gauging. We have the tooling, the handle, and the hose. And because air gauging is a comparative system, it's a gauging system, you have to have the master. And of course, the benefits are fast, ease of use, high performance, high resolution, non-contact, and it works in the shop environment. Now, when you select an air gauge system, there's lots of things to think about. The air tooling is the most critical part of the air gauge system, as it establishes the reference to the part dimension that it's being compared to. So the air system is the display, the tooling, the master, and the part. And we can supply air tooling in lots of different combinations, handles, extensions, etc. But the air plug is the most critical part. It's a hardened steel cylinder with the air passages coming through. They're opposed jets. The air passes into the plug and out the jets. At the proximity of the jet as it's being throttled by the surface restricts the flow, builds up the back pressure, and the air gauge instrument again is what reads that back pressure to give you the dimension. So you can see here's our looks like standard air tooling. This is a through hole design where the air jet is back from the front of the plug, allows us to pass through a hole all the way to the bottom. Or if we have a blind hole, we can work with blind hole plugs that moves that jet very close to the bottom of the bore that you're trying to measure. Now we talked about surface finish being important with air gauging. Well, air gauging, works with back pressure. As the air comes in, the air goes through the jets to the surface being measured. Now, because it's being restricted, we have to have a good surface for the restriction to begin. If that surface has a very roughness profile to it, that air has to fill those valleys within the surface. And if those valleys are too deep, well, you can get a little bit of offset bias based on that roughness surface. Because you can think of a contact measuring system is going to measure only on the peaks of that surface. So if the surface is very rough with air gauging, you can get a offset between a contact and an air gauging system. So that's why we want to know and ask about what the surface roughness is, because if you're measuring a tight tolerance, you need to know and understand the surface finish of the part, as it can affect the end results. But air gauging, because it's a two-point measuring system, you can explore a bore for size, you can rotate a plug for ovality, you can check the bore length for barrel or taper or hourglass shape simply by taking that plug and exploring the bore, looking at the results. So like I said, there's different body styles for through or blind hole. You can have relieved or non-relieved, which means that the body length can be extended, where the whole body length can go into a part. That's especially helpful if you have interrupted surfaces. It makes for an easy insertion. You can add stop collars to get a specific depth on a short land. Plus, you could also, think about adding numerous points of measurement, numerous jets. Two jets is the most common for ID and OD. But if you have a lobing condition in your part, you may want to consider a three-jet application. We can do four jets for averaging and six jets, which average a two and three lobe condition. So lots of different combinations of jetting for air tooling. You can also measure ODs with air rings. If you have an outside dimension, various sizes, 2 or 3 point jet combinations, they can be portable or they can be bench mounted. And also, if you want to measure an OD in the machine, we have air snap gauges, single or multi-jet configurations. And again, they're used in the machine at the point of manufacture. But the greatest thing about air gauging is the actual jet itself. The jets or the sensors are very small and can be positioned very close together. There's probably no other sensor that can do this at the same cost of an air plug. You can get them close as 100 thousandths of an inch, but we can do things to get them even closer if needed. So this provides the capability of doing multi-dimensional geometric checks in a single tool. So you can see some applications here. Measuring some tapers on very small diameters and orthopedic type applications, or some pump type housing conditions where we can measure multiple diameters at multiple heights. And I can't think of any other way of measuring this type of part in so many locations except with air gauging. Like I said, tapers are a great application for air gauging because you can build multiple jets into a small location, or you can use it for machine tool tapers. And if you can measure two diameters at a known distance, you can measure those two diameters and display the actual angle all on one system. Again, no other type of measuring system can do so much in such a small location. And Mahr offers numerous display options out there, whether it be our new C1202 bench amplifier, we have our portable micro dimensionaire. Some customers like to use column gauges and see multiple channels next to each other, makes it a large display for viewing from far away. We have our N1700 PC with cockpit to provide an economical PC-based system, or we can go through full gauging computer applications, storing multiple parts, storing lots of dimensions, and numerous customizable gauging applications. But we're also going to ask about, you know, the typical things when we apply tooling. What's the size? What's the tolerance? What's the location? Surface finish, form considerations, type of display that you want. Are masters required? We can provide worksheets, or we can just come and sit with you. Fox Valley can sit with you to help you decide on the best tooling for your application. I don't know if you have any questions, Steve, but if any, I can take care of them now, or we can wait till the end.
George, no, we do not have any questions that have popped in so far, but for those of you guys on the call, if we'll pause for about 30 seconds to a minute here. If you guys want to chime in with any questions or comments that you may have, we can address those right away. If not, George, I'll let you know when you can get rolling again.
Okay.
Hey, George, it looks like we are good. No questions rolling
Okay.
in so far, so must be doing an excellent job of presenting all the info. So you can
Okay,
roll it.
great.
Go ahead and get started.
Okay, good. So let's just talk about some tips of reliable measurement. And this really doesn't apply just for air gauging. These are common practices that would help with any gauging application, whether it be an air gauge or a snap gauge, set of calipers. These are things that we should just need to do to get the best results. And even though air gauging is very stable, it's a good practice to verify zero position occasionally, based on the number of parts, the environment, and the critical nature of the tolerance. It's good to re-zero occasionally. The air pressure is sufficient to remove liquid contamination from the parts, but it may be wise to subject a part to a cleaning before you use it, especially if it has an oil-based coolant on it. The environment and the manufacturing process probably changes throughout the day. The master and the workpiece should be approximately the same temperature. Again, critical for tight tolerance applications. Dirt, wipe it off the part. And it's good to rotate the plug every now and then if it's in a fixture type of application and you're measuring thousands and thousands of parts, just to move the wear point of the plug around and get the longest life from that plug. So why Mahr for your air gauging needs? Well, we have experience. We've done hundreds of thousands of gauging applications for air, coming up with some very unique and very successful solutions, whether it be using small slit jets, multiple jets, floating air tooling to get into parts which don't have concentric holes into them. I think we have the application know-how to provide some very great and successful application solutions. As I mentioned, Mahr builds the application and accuracy into the system. We make all the air tooling to a standard. The displays are made to a standard, which means that you can interchange them and you'll maintain system accuracy as we publish. And we know accuracy since we not only make the gauging, but we also make and measure the masters. So we make our own rings and plugs and so forth, and we have the tooling. We make our precision Pressomar line to measure those masters to ensure that they meet the specifications that they're